Hi guys. Today we're back with rational functions. So now notice we have two functions and we have both tables. And what we're going to do from these two functions, the numerator function and the denominator function, we're going to come up with the final function, or we can call f of x over g of x, or that'll be the same thing as just h of x. Okay, so here I have f of x when x is -5, f of x is 0. So that'll be 0 over g of x, -9, that'll be 0. And here I have 1 over -8, so -1/8. 2 over -7. Right here I need to simplify, so 3 over -6. Here I can just simplify down to -4. Oh, -4 over 5. -5 over 4. Here, -2. -7 over 2. -8. So now, here we have 9 over 0. 9 over 0 does not equal 0. So when we are trying to divide by 0, that will be undefined, or you will see an error in the calculator. And finally, 10 over 1, it's just 10. Okie dokie. If we were to graph everything from scratch here, those points would be right there. And we need to highlight the asymptotes, the vertical and the horizontal asymptotes. So I have right there x equals 4 for the vertical asymptote. So x equals 4. And I have y equals 1 for the horizontal asymptote. Okay. Now that we have the graph, we have the table, we need to fill out all these things right here. So domain is everything starting from -infinity up to the vertical asymptote, which is 4, right there. And then pick it up at 4 again, and that goes toward positive infinity. Range starts at -infinity, go up to 1, right there, the horizontal asymptote right there, and then starts at 1 again, and it goes all the way up to positive infinity. X-intercept, we can easily tell that it's this one because y is 0. So -5, 0. And we can also tell from the graph right there, the x-intercept right there. X-intercept right there. Y-intercept is when x is 0. So 0, -5 over 4. The vertical asymptote, we can tell from the graph. We already talked about it. X equals 4. Horizontal asymptote. Oh, and please notice that it's from there too. That's when you're trying to divide by 0. That's the vertical line or undefined. Therefore, you can also pull that information from the table. The horizontal asymptote, y equals 1. I got that from the graph. And then, we need to label all the intercepts and asymptotes. So x equals 4, that's the vertical asymptote. Y equals 1, that's horizontal asymptote. We also have the y-intercept right there. Did we get everything? We did. So write the rational function right there. So x plus 5 over x plus minus 4. Okay. Let me tell you a little trick right here, because sometimes the horizontal asymptote is not that easy to figure that out. But you can find out by comparing the degree of the denominator and numerator. So now, if the degree of the numerator is greater than the denominator, there's no horizontal asymptote. Now, if the degree of the numerator and the denominator are the same, then you have to divide the leading coefficients. Now, if the degree of the numerator is less than the degree of the denominator, then y equals 0. And I'm going to refer back to this cheat sheet right here on the next pages. I'm going to let it sit right there for a minute so you can copy. Okay, same idea here. So 0 over 63 is 0. Here I have negative 6 over 48. I can simplify that down to negative 1/8. I'm just going to simplify it all. Okay. So from the table here, we have two of them that I'm trying to divide by 0. This one is 0 over 0. This one is just 18 over 0. There's a difference there. So let's start filling out here, filling out the graph, and then we'll come back and we try to figure out the difference between this one and this one from the graph. So vertical asymptote right there is that x equals 4. So vertical asymptote, x equals 4 right there. And then horizontal asymptote, y equals 1. Horizontal asymptote. Okay, when you look at this, you're like, okay, I can tell that this is from the graph right there. That's the vertical asymptote. Vertical asymptote. So what do I have going on right there when x equals 2? The graph looks just fine to me. So let's come back to this in a little bit. And we're going to try to find out what it is. Domain. From the graph, starts at negative infinity, goes up to 2, because there's something there. There's a gap there. And then starts back up again at 2, goes up to 4, and then from 4 to positive infinity. Now, from the range, I will come back to this. I guess we need to talk about this white elephant in the room right there. Okay. Before I go any further, when I look at this, I need to factor. I know I can factor. So when I look at two numbers that multiply to negative 10, same two numbers that up to 3, I have x plus 5, x minus 2. And I'm going to do the same thing for the denominator. So I have x minus 4, x minus 2. Notice this thing right here. Numerator and denominator factors are the same. That relates to that too. So that's where this factor right there comes from this table right here. Now, that's what we call there's a hole in the graph. It's not an asymptote, but there's a hole, there's a gap right there. So that's how we're going to label this. Right there where x equals 2, right about right there, there's a hole in the graph. Okay, since I'm labeling everything, this is x-intercept and this is y-intercept. And you're like, okay, what is the point of the hole right here? What are the coordinates of that point? I know x is 2, but I don't know what the y is. And that's what we're going to find out. So to find the hole, we're going to use what we have left from our function right here. Notice that after I've factored, I can easily simplify the x minus 2 because they simplify down to 1. So now I have just x plus 5 over x minus 4 right there. And that's what I'm going to use to find the y value that belongs to that point right there on the graph that there's a hole. So x plus 5, x minus 4. So I already know x is 2. I'm trying to find what y is. So plug in 2 for x. And now I have negative 7 over 2 because I got 7 on the numerator and negative 2 on the denominator. So the coordinates for this point is 2 and negative 7 over 2, or negative 3.5. Now, I stopped right there because I couldn't do the range without having that value. Notice that your graph on the range, it starts right at negative infinity. And then since there's a hole, there's a gap right there on the range, right there at negative 7 over 2. And then it keeps going from negative 7 over 2 up to the to the horizontal asymptote, which is right there at 1. And then it starts at 1 again, and it goes all the way up to positive infinity. Okay, the x-intercept is easy. So that's when y is 0. So that's right there. The y-intercept is when x is 0. We already talked about the vertical asymptote. It's labeled in our graph. And the horizontal asymptote, when I compare the degrees, they are both of the degree 2, so same degree from the previous page. Same degree, I have to divide the leading coefficients. The leading coefficient for the numerator is 1. The leading coefficient for the denominator is also 1. 1 divided by 1, that gives me the horizontal asymptote equals 1. Okay, we already labeled everything on the graph. Now we need to write the rational function in factored form. So I have x plus 5, x minus 2, and I have x minus 4, x minus 2. So when you see that you have the same numerator and denominator factors, that's the hole in the graph. Okay, this one right here, that's where the x-intercept comes from. And this right here, that's where the vertical asymptote comes from. And I'll make another video for the next pages.